9 plus J26 ohms is fed from a voltage source through a line having an impedance of 1 plus J4 ohms. The effective or RMS value of the source voltage is 250 volts. Calculate the load current IL and voltage VL. So how would y'all like to do the IL? Yep, that's what I did. And the total impedance is 40 plus J30. And then so I will just be 250 over 40 plus J30, which I get to be 5 angle negative 36.86. Okay, so nothing new there. How do I get the load voltage? We could do voltage division. That's not how I did it, but I will. It's just as easy. So 250 times 39 plus J26 over 40 plus J30 should equal the load voltage. And I get the load voltage is 234 angle negative 3.179 volts, and that's RMS because our source is RMS. Okay, so we did part A. All right, now how are we going to do part B? Calculate the average and reactive power delivered to the load. We don't need to find the max. We can do it in RMS.
Or could you find RMS by dividing the current by the stereo too?
They're already in RMS.
Oh, they already are.
They're already in RMS. Yeah. So, but how do we find? So we've got the current and the voltage in RMS. So how do we find the average and reactive power?
Average power is 1/2 the RMS IRMS cosine of the
The average power does. If we have the RMS, we don't use the 1/2.
Okay.
Yeah. So what I do, and so that is fine. What I tend to do, just because I'm happy with complex numbers, I go ahead and find the complex impedance, and then I just take the parts of it. So I just take V times I conjugate. So the V of my load is 234 angle negative 3.179, and I'll multiply that times 5 angle positive 36.86, and that gets me the complex power, which is 975 plus J650 VA. Now, I will tell you, most people do it separately. Most people find the P and then find the Q. I just find them both at the same time. And then I know that P is 975 watts and Q is 650 VAR. But I will do part C differently just to show you a different way to do it. So part C says find the average and reactive power delivered to the line. So if I look at the line, I have my resistance and I have my inductance. So my average power is going to only involve the resistance, and my reactive power is only going to involve the inductance. And so I know that P equals I squared R, I squared R, I squared R, I R squared. What?
Bottom left, I squared effectively.
I squared, bottom left, I squared R, I squared R. I squared R, and Q will be I squared X. And here I just need the magnitudes. So I, the magnitude of I, was just 5. So 5 squared times R, the resistance was 1, and Q will equal 5 squared times the reactance, which was 4. Not the reactance, yeah. So P is 25 watts, and Q is 100 VAR. And then it says the average and reactive power supplied by the source. So what I did for that one, I've got the voltage, I've got the current, so I did the same thing I did with the load. I said S equals VI conjugate, or S equals 250 times 5 angle positive 36.86. Oh, I have the wrong V. What does the question ask? Supplied by the source. No, I have the right V. Yep. And this equals 1,000 plus J 750 VA. So the average power is 1,000 watts and the reactive power is 750 volt amp reactive. So I hope that was lots of fun. Okay, all right. So that's all for today.